Okay, today we are going to talk about section 2.3, and this section is entitled Additional Displays of Quantitative Data. Our objectives are to learn to construct frequency polygons, to create cumulative frequency and relative cumulative frequency tables, to construct frequency and relative frequency ogives, and to draw time series graphs. And really, this is not a lot different from what we've been doing with our graphs in Excel, and we'll get to practice this in class. To construct frequency polygons. Another way to graphically represent quantitative data is through frequency polygons. And before we talk about what frequency polygons are, we need to have another definition, and that is that of a class midpoint. Now, remember that with data we can divide them into classes, and these classes will have the same width. And if we want to find the midpoint of that class, we can add the consecutive lower class limits and divide by 2 to find the class midpoint. Okay, and what this does is, because the upper limits are often unbounded, they don't actually reach an upper bound, we average the lower bounds because they are bounded. They have an actual integer bound usually. And so that's why we average those two numbers to come up with the class midpoint. And we use this to draw frequency polygons. So a frequency polygon is drawn by plotting a point above each class midpoint on a horizontal axis at a height that's equal to the frequency of the class. And so instead of drawing a bar chart where the bar represents the entire width of the class, we put a point above the midpoint of the class at a height that's equal to the frequency that it's representing. So it's just another way of representing frequency. After the points for each class are plotted, we draw a straight line between the consecutive points. And again, Microsoft Excel has a chart type exactly for this, and we'll show you more about that in class. Here's an example of a frequency polygon here on the right. You can see here we've got a 3-year rate of return, and our class midpoints correspond to our class midpoints over here on the corresponding table. And the frequency height also corresponds to the chart frequency. Okay, now if we look here, what we should have is 0, 4 plus 6 is 10, divided by 2 is 5. And you can see how we construct these. For this one should actually be 14. 14 plus 16 would be the next class up. Divided by 2 gives us our final number. Okay, so forgive me that little typo there. So you can see how we construct our midpoint and how we construct our frequency. And so this series here, the class midpoint, actually goes on the horizontal axis, on the x-axis. And this frequency here goes on the y-axis. And we can see we've selected a chart where we can label each of these two axes with respect to the data they represent. We could also do this using the midpoint and the relative frequency. And again, that would be the same shape of graph with a different scale over here. Now let's talk about cumulative frequency. Cumulative frequency displays the aggregate or total frequency of the category. And discrete data displays the total number of observations less than or equal to the category, or for continuous data, the total number of observations less than or equal to the upper class limit of a class. So what we're really doing is we're adding up all these frequencies, and at the end, the total should be either the number of observations if you're talking cumulative frequency, or if you're talking cumulative relative frequency, the total should be 1, because remember, we're adding up percentages with that. For cumulative relative frequency, we display the proportion or percent of the observations less than or equal to the category for discrete data, and the proportion or percent of observations less than or equal to the upper class limit for continuous data. And right now you're probably spinning around in your head with all these words saying, well, what does this mean? So let's look at an example. This is the same chart. Again, this should be a 14, but you'll forgive me that. Okay, so we have our class midpoint, we have our frequency, we have our relative frequency. Now we want to take and figure out our cumulative frequency. So this actually is based off of the frequency column here. Notice for the first thing, the cumulative frequency matches the actual frequency. But for the next entry, cumulative frequency is actually the sum of the first two entries. For the third entry, it's the sum of the first three entries. For the fourth entry, it's the sum of the first four entries. And so on and so forth. And Excel can add these up for you very nicely. I've actually created these charts in an Excel workbook that I will post to the Edmodo site for your review. Okay. Cumulative relative frequency. Oh, more about cumulative frequency. Notice your total down here matches the total of the frequencies from your frequency column that you use to compute your relative frequency. Now, cumulative relative frequency takes your cumulative frequency and divides it by your total to get the cumulative relative frequency. So for the first entry, 2 divided by 40 should give you 0.05. For the second entry, 7 divided by 40 should give you 0.175, and so on and so forth. And notice these all add up to 1. So you know you've gotten your calculations correct when cumulative relative frequency adds up to 1 and cumulative frequency adds up to the total that you summed in this column here to compute your relative frequency, if that makes sense. And if you look at the formulas that I've put into the Excel spreadsheet, you should see that this makes very good sense. If you have any questions, don't hesitate to email me, call me, post a question to the Edmodo site for everybody to see and respond to. Now let's talk about frequency and relative frequency ogives. An ogive is a graph that represents the cumulative frequency or the cumulative relative frequency for the class. And it's constructed by plotting points whose x-coordinates are the upper class limits, not the class midpoint, and whose y-coordinates are either the cumulative frequencies or the cumulative relative frequencies. So, after the points are plotted, straight lines are drawn between the consecutive points, and we can see what it's going to look like here. Here I've plotted cumulative frequency. In the book, they've plotted cumulative relative frequency, and that's on page, let's see here. That should be on page 99 in your text, the cumulative relative frequency. Again, the shapes are identical. It's just the scale here that we're talking about that's different. So the two things that I've used here are this column of data here. I've separated this into a different column of data. You can't tell that I have because I right justified this column and I left justified this column here. But that way, and you'll see in the Excel spreadsheet how I did that to make it look like it's all one column. That way I can actually post these numbers down here. And I can select my cumulative frequency here. You can see how it all adds up to the total number of 40. Okay. And a lot of times what people do is they will post frequency alongside cumulative frequency. And so you'll have actually two series of graphs here. You'll see the frequency that goes up and down, and then the relative frequency, or the cumulative frequency that adds up. Or they'll also post relative frequency alongside cumulative relative frequency. Okay, those series are often paired together. Now let's talk about a time series graph. If the value of the variable is measured at different points in time, the data is referred to as time series data. And its plot is going to be referred to as either a time series plot or a time series graph. Make sure you always put time on the horizontal axis. Okay, we will be talking more about this when you get to class, and we will have you construct a lot more of these in Microsoft Excel to get some practice with this. But for right now, I would like you to go into the Microsoft Excel worksheet that I'm going to post to the web and make sure you're familiar with all of those formulas that we're going to be using in class. See you in class. Bye.